In this example, we'll find the absolute extrema of f of x equals the quantity x minus 1 divided by x squared plus 1 on the interval from 1 to 5, which is a closed interval, so it includes the endpoints. Now, you might be a little worried that this could be discontinuous, but look at the denominator. This function would be discontinuous if the denominator was equal to 0, and this denominator you're always squaring and adding 1, it's always going to be positive. So there's no chance for us to have any discontinuities, so we do have a continuous function here. So what I need to do is find my critical numbers. So I'm going to take my derivative with the top being u and the bottom being v. So I have v u prime, so x squared plus 1 times 1 minus u v prime, which is the quantity x minus 1 times 2x, all over v squared. So the quantity x squared plus 1 all squared. Since I need to find the critical numbers for this problem, and that's going to be where this top is equal to 0, I'm going to try and simplify that top a bit by multiplying the 2x into each one of these terms and then combining it with the other. Remember, I'm also going to have to distribute that negative. So when I do that, the top becomes x squared plus 1 minus 2x squared, and 2 negatives times the 2x gives me plus 2x. Combining those like terms on top gives me negative x squared plus 2x plus 1 over the quantity x squared plus 1, all of that squared. In order for this to be equal to 0, we're going to have to set the top equal to 0. Remember, the bottom's never equal to 0, so we're not going to have any places where this derivative is undefined. So I'm going to set minus x squared plus 2x plus 1 equal to 0. A quick look at that says that's going to be one that I don't think I can factor easily. So the way to find the solutions to this is to go ahead and use the quadratic formula. So I'm going to go ahead, take my minus x squared plus 2x plus 1 equal to 0, and I'm going to write out the quadratic formula, which is minus b plus or minus square root of b squared minus 4ac all over 2a. Looking at my quadratic function here, I'm going to substitute a equal to negative 1, b equal to 2, and c equal to 1 to get minus 2 plus or minus square root of 2 squared, subtract 4 times negative 1 times 1 divided by 2 times negative 1. A little bit of simplifying leaves me with negative 2 plus or minus square root of 8 divided by negative 2. I can write square root of 8 as 2 square root of 2, and now factor out a 2 and cancel it with 1 that's on the bottom. When I do that, I'm left with 1 subtract or add square root of 2. Now this is kind of interesting. 1 subtract square root of 2 is about 1 subtract 1.4. That's a negative number. That's not in my interval up here. I only want the things from 1 to 5, so I'm only going to keep the critical number at 1 plus square root of 2, which is about 2.4. So the critical number that I want to work with and test is going to be the x equals 1 plus square root of 2. I'm going to make up a table that includes that critical number and these two endpoints, and I'm going to plug those numbers into the original function to get the y values. So when I put those x values into the original function, for 1 plus square root of 2, I get approximately 0.21. For 1, I get 0. And for 5, I get approximately 0.15. So the very highest y value is the absolute max. The very lowest y value is 0. So that tells me now where my absolute maximum and absolute minimum are. And that because I threw out that other critical number, they both lie inside the closed interval from 1 to 5.